Suppose you have a landscape, or terrain, and you want to find which direction to go in order to climb up or ascend as fast as possible. In 3 dimensions, you can think of a function f of x and y that turns 2 numbers into a height. Pick a point on the ground, and the function tells you how high you are. Now what we want is local steepest descent. At one point, there isn't a single slope, like you would see in a single variable derivative. There are instead infinitely many slopes, one for each direction you could choose to walk. We then introduce a way to organize all these directional slopes into something simpler. Notice the change you experience doesn't depend on the direction itself. It depends on how aligned that direction is with the uphill tendency of the surface. When you move with this direction, the height increases quickly. When you move against it, the height drops quickly. When you move perpendicular to it, there's essentially no change at all. This single vector encodes all local slopes at once. For any direction you choose, the rate of change is determined by how much that direction overlaps with this vector. And when the 2 directions line up perfectly, the increase is as large as it can possibly be. As a consequence, directions that stay on the same height, level curves, must be perpendicular to the gradient. They're directions of 0 overlap. This is why they show up in physics, numerical methods, and learning algorithms. So for a function f of x and y, the partial derivative with respect to x tells you, if I move only in the x direction, how fast does the height change? Similarly with the partial derivative with respect to y. These are direction-specific measurements. Now take any direction in the plane, represented by a unit vector v. Moving in direction v means move v of x in the x direction and move v of y in the y direction. For a small step, the change in height is approximated by the partial derivatives. Rewrite this change in vector form, and that vector of partial derivatives appears because it is the unique vector whose dot product with a direction vector gives the directional rate of change. That vector is the gradient.